Good morning, good afternoon, good evening to all our viewers over the world. It's another exciting moment with King of Mathematics. Like I always say, every child is what? Wonderful. We are here to show you another important topic. Actually, the main reason behind this topic I will be teaching you today is based on the fact that one of my students sent his assignment to me to help him solve it. Like I tell you, we also help people in solving assignments, and our price is very affordable. So what I did is I solved it for him, but I want us to also benefit from this particular question. And this question he gave to me is on this topic I call sequence and series. When you hear about sequence is one thing that we'll be playing with right from our primary school. When they give us 2, 4, 6, 8. We learned all those sequences by our multiplication table. But now we are going to show you the higher dimension of our sequence and series. And I will be explaining the difference between a sequence and also a series. Alright, join me as I go to the board now to show you the topic, like I said, sequence and series. Now, this is an example of a sequence. This is what we call sequence. So, we want to play with this first so that I can put you into the topic itself. When you have 2, 4, 6, 8, what you need to do is to check what is the difference in those numbers. You can see from 2 to 4. The difference between 2 and 4 when you count it is what? 2. That means the distance of 2. How do we get that? By subtracting 2 from 4. Also, look at 6 and 4. The difference is also 2. 8 and 6. The difference is also what? 2. That means to get the other number, what you'll be doing is by adding 2 to your penultimate number. That is the number before. That's 2 plus 2 will give you 4. 4 plus 2 will give you 6. 6 plus 2 will give us 8. Definitely, I know you are doing some addition over there. 8 plus 2 will give us 10. That makes that place to be 10. Likewise here, 10 plus 2 will give us 12. We are done with the first one. So if you have a sequence like this, you have to check what is the common difference. We call it common difference because you can see we have 2 here, 2 here, 2 here. So it's a common difference. Let's go to the second one. We have 3, 5, 7, 9. These are even number. This is odd number. You still have to check what the difference between 3 and 5. 5 minus 3 will give us 2. 7 minus 5 will give us 2. 9 minus 7 will give us 2. That means there is an increment of 2, 2 as well. It's not all the time that the common difference is 2. We have some places whereby it can be 2, it can be 4, it can be minus 1, it can be minus. We'll see it as the case may be. Now, to get this, that will be 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 2 will give us, that's 11. 11 plus 2 will give us 13. That's all for the second one. Then let's go to the third one. We have 4, 8, 12. Look at this. It's moving in distance of 4. 4 plus 4, 8. 8 plus 4, that's 12. That means to get the next 2, that will be 12 plus 4. And what will 12 plus 4 be? That will give you 1 and 6. That's 16. So when you have your 16, 16 plus 4, that means this is what? 20. Now, before I call out this particular topic, which is arithmetic sequence. What is arithmetic sequence? We have different types of sequence. First, you know that we have arithmetic, which means addition, dealing with addition. And it's involving what we call common difference. That is a difference between the two. You know, opposite of addition is what? Subtraction. If you want to get your inverse answer, you have to subtract. Now, the second one is what we call geometry. But today, we will not be dealing with geometric sequence. We will be dealing with arithmetic sequence and series. Now, arithmetic sequence. The first term, we have what we call the first term. The first term is called A. The second term, this is the first term. The second term is called A plus D. You can see, just like I was telling you here, we have 2. The difference is 2. So the difference is 2. That will be 2 third term is a plus 2d. Why? Because if you look at it, this from here to here is what? 2. Here will be, if you check this place now, this will be 2 times 2, that's 4. That is, I have 4 to this 2. You are going to have 6. So that's why you are having a plus 2d. So this is what we call first term. We call it first term, second term, third term, fourth term, and so on. Like that. So that's what I've shown you here. U1, that's first term. And we call it, this is first term. This is called second term. Third term. So we have first term A, second term is A plus 1d, third term is A plus 2d, fourth term is A plus 3d. What do you notice? You notice that as you are going to each one, the difference is going to reduce by just your number of term minus 1. Because look at it. A for second term is A plus 1d. That is 2 minus 1, that's 1d. If it's third term, you got a plus 2d, that is 3 minus 1, that's 2. 4 minus 1, that's 3. That's why you have a plus 3d. Now this is going to have fixed term, it will go a plus 4d. If you go to the sixth term, it will be a plus 5d, and so on. That's why we were able to come about wherever you want to stop, which we call the last term. We call this un, or you also call it l, that is last term. So this a is first term, n is standing for number of term. So a is first term, let me use first term, n equals number of terms, and d is our common difference. So the A is first term, the N is number of terms. That is, we are asked to find 2 terms, the first 2 terms. That's the number of terms. That means N will be 2. If it's third term, that will N will be 3. So the difference is common difference. So by the time you put it, if you are asked to find the formula for 11 term, it will now be A plus 11 minus 1. That's 10. Then D, that will be A plus 10. Then you'll be able to get this formula back. Okay, let's go to example so that we'll see how to find common difference. Find the common difference in each of the following arithmetic sequence. The sequence are 5, 8, 11, 14, 17, telling you that it continues. That's not the end. And we have B, 83, 77, 71, 65, telling you that that's not the last number. Then let's go to the solution. The common difference, like I told you earlier, is called D. Then to get your D, it is called, some books use U1, some use T1. Some books, so we can either say U1 or U2 or T1, T2. Now I'm using T2 here, so D will be second term, that means this is my T2, second term, minus first term. The only way whereby you can know whether it's having a common difference, especially when you're dealing with arithmetic sequence, is the D must be the same. For when you check your T2 minus T1 should be the same thing as T3 minus T2. That's what they're saying. You have to check this and check whether they have the same common difference. T2 minus T1 will be the same thing as T3 minus T2. That is second term minus first term, or the same thing as third term minus second term. Just like you check in the first one. So 8 minus 5, you can see our second term is 8, our first term is 5. 8 minus 5, but the same thing as 11 minus 8. So that's why we are having 8 minus 5 is 3, and this is also what? 3. So that means our D is what? 3. Having done that, we are done with question A because we only asked to find the common difference. Let's go to the B part. You see T2 minus T1 must be the same thing as well, T3 minus T2. That's the only thing that can make us have a common difference. So let's check. That means 77 minus is 3 must be the same as 71 minus 77. And that's to be checked minus 6 minus 6. That means our D is minus 6. That's just how to calculate your common difference. Now you can see that this is very simple compared to the way you've seen this topic before. Alright, if you now know how to find your common difference and you know how to the formula to find your last term. Eventually they ask you to find the last term, you use your formula for your last term, which is a plus m minus 1d. For instance, let's say you are asked to find u9 for this equation. That would be a plus 8d. Then we now have our first term is 5. That's 5 plus 8 times, we've gotten our common difference to be what? 3. So we have 5, this first term, the 8 normal, then your d is 3. So 5 plus 8 times 3 is 24. So let me write it, 5 plus 24. And 5 plus 24, that will give you 29. That means the u9 will be 29. So that's just how to do that. Okay, so let's go to series. So many people make mistake of this particular topic. They call sequence and series, they call them the same, and they are not. They are quite different from one another. Sequence is a number. When you have your numbers with your commas, you give them that is, you have a breakdown. But when you talk about series, it's a sum of all your sequences. Like now, just like we have here in this example, we have 2, 4, 6, 8, 10, 12. If I want to turn it into a series, I will have to introduce what I call addition form, plus. So I will have to turn it into 2 plus 4 plus 6 plus 8 plus 10 plus 12. That's what turns into a series. So that's the difference between a sequence and a series. So it's all talking about, anytime you see this sign is called summation. And the meaning of summation simply means you should add all the numbers that you have in your sequence together. So, and let me read out in case for those that didn't know how to read it, that's summation of summation of ui, that is of your ui, taking your I from 1 to n. Summation of ui, taking this I to be 1 to what? N. So if you want to do that, means this is meant to be u1, which is called a, plus u2. By the time I substitute I to be 2, that will u1 plus u2. And u1 is given by the formula a. Just like I said, that's first time. u2 is a plus d. So that's why I'm not using u1. So this is still the same thing as u1 plus u2. So that's still the same thing as u1 plus u2 plus u3 plus dot to your last 10. Also, you have to check when you now turn the ball, when you take it from the backward. When you take it backward, that means you have your last term, which is un. You want to get the number up before it. You know that is going to be your last term minus the common difference. For instance, look at this. If I want to get, let's say we are starting from 12. To get this 10, that would be what? My last term, which is 12, minus my common difference, which is 2. You know, that would be 12 minus 2, that would be 10. If I want to get this 8, that would be 12 minus 2. You know, that would be minus 2d. 2 times 2 is 4. That's 12 minus 4. That would give me 8. So that's why we are having un plus, that is, we are taking it from the back here. So un plus un minus d, which will be my second to the last term. This is third to the last term. Un minus 2d. Up to when you have your a bar. So what you do is you add the two equations together. By the time you add it together, you see that you have these numbers. This will be summation. You have it twice. That's 2 summation of ui taking I from 1 to n. You now be equals to, you have twice of all these ones. So which will, that's n into bracket a plus your last term. You are going to get this formula. This un is also what we call last term. So dividing both sides by 2, you you have n over 2 into bracket a plus un. So also, but don't forget that un has a formula which is a plus n minus 1d. Un has a formula which is a plus n minus 1d. So that was what we substituted. Then un will be equals to a plus 1 minus, which is also the same thing as L. Substitute it in this equation, you have n over 2 a plus n minus 1g. So by the time you have a plus a will give you 2d. You have n minus 1, then you have g. So anytime they ask you to find the sum of your sequence, which is of your series, which will return to your series you use for arithmetic sequence. Let's say another one for geometric sequence. But we are dealing with arithmetic sequence. You use this formula. This is the first formula that you use. And if you don't want this formula, you use it when you are giving n, the number of times you are giving the first time and you are giving the last time. But you use this one when you are not giving the last time, but you are giving n, you are giving first time, and you are giving your common difference. Okay, so let's go to the question I was talking about. Most of you have seen this book. This is what they call scholastic. That is furthermore scholastic for SS1. The question the boys asked me to solve is actually gotten from this. Is written by T.R. Moses. So the sequence and series is a direct question that he gave to me. That's question number 22. Question number 22. I'm going to write the question on the board and I'm going to solve the question. For those of you that you are probably in SS1 as well and you still have similar problem on how to solve this question, I will solve the question and you see the solution. Open to page 72, you see it under exercise 5. The question is question 22. Now, question 22 says that Mr. Momo starts a job with an annual salary of 6,400 naira, which increases by 240 naira every year. After working for 8 years, Mr. Momo is promoted to a new post with an annual salary of 9,500, which increases by 360 naira every year. Calculate Mr. Momo's salary in the 15th year of service. Second one is Mr. Momo's total earning at the end of the 15th year of service. This question is actually hard for many students to solve. Now, let me tell you the solution is this. The Mr. Momo's start salary, the amount is starting with, which is 6,400. You call it your first term, which is termed as A1. Then Mr. Momo's salary on 9th year. You know, at the 9th year we are told that he has 9,005. So you call that 9,005, that will be our A2. I will explain the reason why it's A2. The increment every year, that increment of every year, that is for the first year, every year, that is going to be your common difference, which I call G1. Then the increment for the second one, after the 8th month, that after the 8th year rather, which they said increases by 360, that's going to be your D2. That is your common difference, second common difference. So let's go to the first question. His salary at the 15th month. Then I decided, so that you can understand this thing very well, let's list it. The first year is 41. That is first year. Second year T2, T3, T4, T5, T6, T7, T8, T9, up to what? Your T15, which is the 15th year. But we are told that from this first year to the 8th year, his common difference is 240. That's how 240, 240, 240, up to the what? 8th year. Then in the 9th year, he was promoted. Normally, we get promotion in our work when you at least have a very long time with them. So as a senior servant there, they increase your salary and take it to another scheme of payment. So he's now having 360 as his annual increment. So that means from here, this has come to a first term now. That's why T9 is now a first term. which is going to be, and let's now see how many years he was able to work till this 15 year. We have 1, 2, 3, 4, 5, 6, 7. So that's why in this place we will have our T9, which is the 9th term, to be the, which is 9,500. We were told that at the end of the 8th year, his salary is now 9,500. That means 9,500 is now the 9th year. Do you understand? So the 9th year, that means is going to be our A2. T15, which is what they asked us to calculate on the 15th year, will now be same as 1, 2, 3, 4, 5, 6, 7. So that means you are going to calculate the increment. Since you know the 9th years are not, they will calculate the increment of 360 for good 7 years, which will give us the 15th year's annual is 15th year's salary. So that's why I said T15 is now going to be equal to T7. And your D2, which is your common difference to your 316 naira. And from our formula that I gave you, if you want to find T7, that's going to be n minus 1. So n is 7, that will be A into bracket n minus 1. That's 7 minus 1, which will give us 6. But 6 D2, because we are making of this second difference. So that will give us 9,500, which is our A2. Let me write A2 here. So A2 plus 6D2. So that's 9,500 plus 6 times 360. So this is 9,500 plus 2,116, and you get your final answer to what? 11,660. So this is the T15. That means by the 15th year, Mr. Momo so by 15th year, Mr. Momo will be paid a sum of 11,660. That's for that 15th year alone. Then the second one is now talking about Mr. Momo's total earning at the end of the 15th year of service. That is, for good 15 years that he has been working for them, what is going to be the total earning he has had? So in this case, that's going to be, if you look at it, for the first 8 years, his increment is 240. So that means we are going to have, that's where we are talking about the series. Where series will come in, we're dealing with sum. You know, I told you the difference between sequence and series. The first one is sequence, this second one is series. That's going to be S8. But what do we have left here? That's what? 7 terms. So that's what I'm saying. Sum of 15 terms will be the sum of the first 8 years plus the sum of the 7 years after the 8 years. So that will make your 15. So, and to get your S8, you know, using our formula, I told you is either you use n over 2 into bracket a plus l. But I told you, if you are not given the last time, you use n over 2 into bracket 2a plus n into bracket n minus 1 bracket d. That's why we are having d. But don't forget, in the first 8 years, we are having a1 and d1. That is, you are going to make use of 6,400, and your d1, that's 240. So that's why I'm having 8 over 2, which is n is 8 over 2. 2, this 2. A is 6,400 plus n, 8 minus 1 times 240. That will give us 4. 8 divided by 2, 4. That will give you 12, 800 plus 7 times 240. And that will give us 4 times into bracket 12,800 plus 1,680. By the time you sum these two together, you are going to have 14,480. Then you multiply it by 4. That means by the end of the 8th year, he has been able to make a earning of what? 57,920. Then the 9th year is package has changed. So that means why we are going to calculate for the next 7 years. So that is going to be the same formula n over 2, but this time around we'll be making use of 9,005, which is our A2, and D2, which is what? 360. So that will be 7, n is 7 over 2 times 9,500 plus 7 minus 1 times 360. That will give you 7 over 2. This times this 2 times 9,500 will give you 19,000. 7 minus 1 is 6 times 360. You have 6 times 360 there. Then 7 over 2, you have the 6 times 360 will give you 2160. Then adding this together, you have 21,160. Divide this 21,000 by 2, you are going to have 10,580. Then multiply your 7 by 10,580, you have 74,060. That is earning after the 7th year, which is up to the 15th year. This S7 is up to the 15th year. That is T9 plus T10 plus T11 plus T12 plus T13 plus T14 plus T15 is equal to 74,060. YT1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 plus T8 is 57,920. And what we are asked is to find the summation of T1 to T15. That is T1 plus T2 plus T3 plus T4, T5, T6, T7, T8 plus T9, 10, 14 up to 15. So that will be this plus this. We now add this one plus this. That will give you S8 plus X7. Sum of S8 plus that will give you 57,920 plus 74,060. And that will give you S15. Sum after the 15th year. So which will give you 131,980. That will be the answer for the question. And that is how I was able to actually solve the question, and I was very happy because he got everything in class and he was given a good grade. So therefore, please, if you have any question, always feel free to drop at the comment section or contact us via our number either on WhatsApp or you call us. Or better still, you can still go to the our other platform on TikTok, which is still with the same name, King of Mathematics. Until the next video, like I always say, every child is wonderful. Make sure you subscribe, on your notification, like, share, and comment. Bye.